Hello, welcome to another edition of Cracking the Cryptic. One of the things we're trying to do on the puzzle is to branch out a bit and do other types of puzzle. We've looked a lot at Sudoku and Killer Sudoku, and obviously the Times crossword so far, and the listener crossword. But we haven't done much with Japanese pencil puzzles and the wonderful Nikoli.com site, which we've plugged before. Really is worth a look if you like puzzles. I think it costs about £2 a month to subscribe to Nikoli.com, and you get 3 or 4 puzzles every day. They're all hand designed, which means they're incredibly good quality. And today's puzzle, which was a prize puzzle, was an Akari. Now, for those of you unfamiliar with Akari, the rules are quite simple. The idea is that you need to light up every single box in the grid. Whenever you put a light in a cell, as I've just done there, the light extends as far as it can, horizontally and vertically. And the numbers in the black boxes indicate how many lights there are in orthogonally connected cells. So the most obvious example being 4 here, that means there are 4 lights in the 4 connected cells. Now, the reason for having a look at this puzzle is twofold, really. Firstly, it is a thing of wondrous beauty. This is an absolutely stunningly awesome puzzle. And secondly, it's about as hard as an Akari will ever get. So by covering the techniques necessary to solve this puzzle, we think you can solve almost any Akari there is once you've got a handle on this one. So without further ado, let's take a look at how you do it. So, one of the obvious things that I would always do when solving a puzzle like this, if we look at this one square where the cursor is at the moment, you can see that you can't have a light here, because if the light was here, this one cell would now have no lights connecting to it. So by placing a dot in this cell, you're indicating that no light can appear there. And that's very useful. The most, obviously we could extend that and do all of the zeros, etc. But I don't intend to do that here. But that's just to show you a good technique you should be employing when you solve these puzzles. The first interesting step to note is these two twos down here. I mean, to think about how the lights may be arranged around these two twos. So it should be clear to everybody that if we were to place the two twos around this right-hand 2 like this left-hand 2 is now broken because it could only contain a single light around it. So from that we know that this arrangement of 2's on the right-hand 2 must be incorrect, and there must be a 2 here. And corollary of that is there must be a 2 here as well. And we now know that the other 2 2's, or the other 2 lights that surround these 2 2's, will either be in this configuration or in this configuration. And that means that there can't be any lights along the whole string of horizontal cells along these 2 lines here where the cursor is moving. And that's quite useful. Now, I suppose one of the downsides of hand design puzzles is that what you tend to find is when you find a bit of logic like that, it will lead naturally into the next bit of logic, and you can either dislike that or like it. I tend to like it because it shows the puzzle's had a lot of thought in terms of how it's been created. So here, this light here has limited this one. This one can only have a light in this position. And now we come to a second piece of fairly amazing Akari logic, and that's the thing you have to notice now. I'm going to highlight them. There's these 4 cells here, believe it or not. We can now say something for sure about these cells, because the configuration of the lights around them is now limited let me show you what I mean. If this light was here, then it can only be in either of these two cells. This would force a chain of lights around like this. Whereas, if the lights were here, this would again force the reverse chain of lights around this sort of big box of ones and the 2 down here. I mean, one thing we can say with certainty is that this 2 must have, this must be a light. And what this means is that we can actually eliminate the possibility of there being a light in any of these cells that I'm highlighting now. Because we know that whichever of these squares that we pick the light around this one, all of these cells won't be able to contain lights. And similarly, we know also that we need to use the fact that we've now worked this out to find our next piece of logic. And we can find it here with these 2 disconnected 2's this time. It's the same principle that we discovered over here where the cursor is. It's just harder to spot because the 2's are so far away from one another. But again, let's just show you what I mean. If these 2 2's both contain lights, this 2 fails. So this cannot be an arrangement of the lights around this 2. These 2 2's. And similarly, we now know that the other 2 lights around these will either be in this configuration or this configuration, which means that we can extend our vertical lines, or vertical dots this time, in the way that I'm showing you. Okay. And again, we discover something else as a result of this piece of logic, because now we can look at this 1 and this 2. Oops, sorry. And you can see that whichever light I place around this 1, it's restricting this 2 somewhat. It's definitely restricting one of the open positions for the lights around this 2 in such a way that this is forced to be a light, and the other one of these 2 will be the other light. So again, we get to extend horizontal dots this time along these directions as shown. And again, now we can look at the 3 and the 1, and we know that a light is either here or here around the 1. Either way, it's going to restrict this 3, and the 3 must therefore have 2 lights in these 2 positions. We don't know which of the other 2 it'll be, but we do, again, we can draw our extension of the horizontal lines, as I've shown here. So we're making reasonable progress. And the amazing thing about this puzzle is, although it does feel like we're making reasonable progress, we haven't spotted the clever bit yet. So we've managed to limit this one up here. This can only appear like this, which is, I suppose, helpful. And now, what can we see next? Where's the next place that we can go? Well, I guess we can spot that there's only one position to put a light on here. And obviously when we extended the 3 as far as we could horizontally here, we needed to do the same thing in this direction, which would have limited this 1 to only this position. And now we find another of these extraordinary rectangular restrictions. So this time we need to have the vision to see that this one, this one, this one, and this one form a rectangle, an unimpeded rectangle, in which whichever of these positions I choose for the light around this one, that will just restrict around the chain of 1's all of the cells as shown here. It doesn't matter which way round it goes, all these cells will be restricted. And again, we now are able to spot that these two 2's here have exactly the same relationship as the other pairs of 2's that we've seen before, i.e. I can't put two 2's around the outside here, or two lights around the outside of the 2, because that's going to cause me a problem with the other 2. So both 2's need to have lights in these positions, and I'm able to restrict all of the vertical positions that I'm showing you here, and all the way down like so, which means this one obviously can only appear in one position there. Okay. And now we come, I suppose, to the pièce de résistance in this puzzle. You know, the design that has gone into this I find just beautiful. So we've seen these rectangular boxes of 1's being important. Well, I can tell you that there is now another of these rectangular boxes of 1's that you can find in this grid. It's just somewhat bigger than the ones we've identified so far. And it works on the outside of the 1's this time. So I'm going to highlight the ones that are involved. So I'll show you with the try button. It's this one here, this one here, this one here, and this one here. And you can see that whichever way we configure the ones around this rectangle, all of these, all of the other cells in the horizontal and vertical planes will be restricted. So quite incredible, really. Let's draw this in. As I'm showing you here, hopefully it's clear. There we go. Drawing this one in yet, sorry. That's what's coming as well. And the amazing thing about this extraordinary configuration of 1's here, and the restrictions that it leads to, are that the setter has somehow managed to construct exactly the same thing again with an even bigger rectangle of 1's, because now if we look at this one, this one, this one, and this one, we can see that exactly the same thing is happening again, just in an even bigger rectangle. So we're able to eliminate this entire column. Oops, a couple of mistakes there. Let's just eliminate those. As shown. And finally, we're able to put in another light, which is in relation to this 2 here, which allows us to complete that earlier rectangle of 1's and 2's that we found, and also to place this light at the top of the grid. A quite incredible series of sort of logical deductions flowing from this sort of 1's sequence going around the very edge of the puzzle. Truly amazing piece of construction. And one of the things we can now see again from the new restrictions we've placed is that this 2 here and this 1 here are restricted. Oops. This, i.e. you can't have these 2 lights here and this 2 because this 1 would have no possible solutions. So we can place a 2 here, and we're able to draw in some restrictions for the rest of the cells in the line as shown. And we see yet again the same thing happening in this vertical 2 and 1 up here again. Again, this would be impossible because this 1 would be too restricted, so we can place the 2 here. And these horizontal cells here, and now this 1 is left with only one possibility, so we should fill that in as shown. And we can see again now these 2 1s now, whichever position I place the light in, the other 1 is then forced. So there can be no 1s in the positions that I've just highlighted there. And we've now managed to limit this 1 to only one possibility. So let's fill that in and see whether that helps. And obviously this cell, this 1 here, now only has one possibility. This 1 only has one possibility. This 2 and this 1 are now forced, shown here. The puzzle's finally starting to give up its secrets. What an incredible puzzle this has been. We're almost there now. There's only one way of reaching this square here. Looks like that. Similarly with that square. There's only one place for the light here. Only one place for the light here. Now really starting to cook with gas. Oops. Finally, we've managed to identify the correct orientation for one of the large rings of ones. This is really a quite remarkable puzzle. And I think we're finally home. There we go. I think we're ready. Congratulations. Wonderful puzzle and well worth running through. I hope that was interesting, and we'll see you again next time.